Hello again, and welcome back to our technical series on how to replace artificial colours in foods and drinks. During today's webinar, we will tell you about natural alternatives to artificials that can be used in snacks. Our journey will take us first through an overview of snacking, its definition, and the technologies involved in their manufacturing. Then we will revise the technical factors that affect colour performance in the context of artificial colours replacement. And at the end, we will share a range of naturally derived colour options to replace artificials in snacks. Let's begin by aligning on what are considered snacks for this presentation, their processing, and what technical factors affect colour selection and performance. Snacks can be defined as any food that is eaten between main meals, but with a blurring definition of what a main meal is, it's difficult to pinpoint exactly what a snack is. It could be anything from a piece of fruit, a baked product, nuts and seeds, or industrialised cereals, tubers and grains. In general, most of the marketed snacks are manufactured through processes that prolong their shelf life and improve their palatability, such as extrusion, like in puffs, frying, like potato chips, baking, like in crackers, and robing and slab forming, like in cereal bars. The main ingredients used in snacks have been shifting with the years, from an almost ubiquitous use of corn and potato to the inclusion of alternative sources like pulses, seeds and grains, like quinoa and rice. There are several factors that can influence how natural colours perform in a snack, like the colour of the base batter or dough, its physicochemical composition, the temperature and duration of the thermal processing, the use of clear packaging or any sort of light exposure, the colour dosage rate, and the flavour expectations and how it pairs with the selected colour. Looking then at the base colour, you can see that the type of cereal, vegetable or flour used can have a huge impact on the base colour you are working with. If you have a corn base, you might have a yellow starting colour that will give a warm twist to any colours you add, which could mean a challenge to get cool shades like purples or greens. But if you have a potato starch base, you'll have a near pure white base to work with, which will not have an impact on your added colours. Here you can see an example of extruded snacks made with 3 different base flours: chickpea, corn and potato flour from left to right. They are all coloured with the same dose of an annatto extract, and the differences in hue, sharpness and intensity are noticeable. Chemical factors also influence natural colour performance. Divalent metals can form complexes with colours like annatto and carmine, causing pigment precipitation and changes of hue. Anthocyanins are also affected by metallic cations, and an interesting case is what we see now on the screen. Turmeric is an excellent replacement for FD&C yellow 5 in many applications. In the image on the lower left, you can see that when applied in milk, it appears a bright greenish yellow, but in the pretzels on the right, the same colour appears golden orange. Why is that? pH is known to shift the maximum absorbance wavelength of many natural colours. In the case of turmeric, it turns redder as pH increases. Pretzels are made by dipping the dough in a diluted lye solution before baking, turning the turmeric a more orangey shade. As a takeaway, the selection of the natural colour must consider the chemical factors involved in the main base, the ingredients, the quality of water, and the presence of other food additives used in the recipe. Thermal processing is another factor that should be considered when selecting colours and assessing their performance in an application. Different pigments perform differently when exposed to heat. We can see here at the top crackers coloured with 2 of the most heat-sensitive natural pigments used in foods, red beet and spirulina. You'll notice that the crust is sufficiently coloured, but there is an obvious fade in the cooked dough underneath. On the bottom, we have turmeric that is a heat-stable pigment and shows no colour fade during the heat processing. We also have a formulation of an anthocyanin, which could fade in prolonged thermal processing, but in this cracker recipe, with a 20-minute bake time and low water activity, it survives and gives a good homogeneous result. Another factor we need to consider which can affect colour performance in a snack application is light exposure. Here you can see 3 different pigments that give nice yellow colours in a yoghurt coating on a rice cake. Half of the rice cake was covered to protect it from the light exposure. Then it was placed in a 24-hour light box for 19 days. You can see that turmeric and carotene have faded, where safflower has remained stable. This is showing the importance of considering the end packaging of the snack and whether, for example, it has clear windows, which could cause fading on the supermarket shelf. This can guide your decision on which pigment to use for the colour target you have in mind that has the best light stability. Another way to increase the light stability in application, rather than changing the pigment itself, is to consider using a colour with more antioxidants in the formula. The last factor that we will talk about is flavour. There is a strong correlation between colour and flavour identity, as well as an important effect on the perception of saltiness, sourness, and flavour intensity. Warm reds can send cues for the identity of a chili flavoured snack, while a pinkish red can evoke a strawberry flavour. The bright hue of turmeric brings recollections that match with a citrus flavour, while a warmer yellow matches better with the umami notes of cheese. Yellowish greens can be linked to the spicy notes of wasabi, while bluish shades match better with fresh mint or basil flavour. But how do we add colours to snacks? There are a good number of ways to add natural colours to snacks, and that will depend on the nature of the matrix. Is it a water-soluble base or is it mostly oily? The structural composition of the food product, is it just one phase or more? Do we have layers, fillings, coatings, etc.? The effect one wants to achieve, and of course the processing steps, among other factors. Let's review some ways to add colour. First, we are going to look at the dough or premix of the snack before any thermal process. In baked or fried snacks, it is usual to add the colours in the first mix, be it through a dry blend with the flours or other dry ingredients, or dissolved in any amount of liquid that is used in the formula. Water-soluble colours are preferred in fried applications to avoid colour bleeding into the oil or packaging. In extruded goods, water-soluble colours, both in powder and liquid form, can be used, depending on the formulation of the remainder of the premix and the equipment setting. The formidable mechanical work delivered by the extruder screw grants a homogeneous colour distribution. Heat-stable colours are required in snacks that are baked, fried or extruded. Another form of adding colour to snacks is through seasonings. In high-tax snack bases like chips and crisps, the seasonings can easily be added in dry form and will evenly coat the snack on application. One can use powdered colours to pre-blend into the seasoning mix for great colour effect. Artificial lakes are used often to get a uniform superficial colour. Another way to add colour to snacks are oil slurries, in the case where there is low tack. Solid ingredients like cheese powder and spices are suspended in a blend of edible oil, which is then sprayed onto the surface of snacks, either in a rotary drum or on a conveyor belt. Traditional snacks include artificial lakes as colours for oily slurries, as they provide a uniform coat on the snack surface. Before we jump into options for replacing artificial colours, let's take a quick look at what lakes are and why they are used so we can better understand how to replace them. Lakes are insoluble pigments that are made through the reaction of organic dyes with metallic salts. The lakes used in foods are made with alumina, and their insolubility permits its use in low moisture, high fat systems, or where colour migration needs to be prevented. They are widely used in applications like snack seasonings or oil slurries for just that purpose. They uniformly coat the surface of snacks with vibrant shades and don't bleed onto other layers. But as you will see, we now have the chance to substitute artificial colour lakes in snacks, not only by achieving close hue matches, but also by providing similar technical performance with various natural colour technologies. In dry seasonings, we have our Microma Plus powders that are water-soluble colours micronized in the solid state to provide extraordinary surface covering and homogeneous bright colours. The colour won't bleed in oil-containing applications like in seasonings for fried chips. In oil slurries or coatings, we can also use Microma powders or Microma liquid dispersions in oil. Their finely suspended particles can be incorporated easily into the oil, and their large surface area reflects lots of light, granting a superior colour expression compared to concentrated or standard natural colours. And finally, the colours can be mixed to get loads of different shades. For snacks that only require small flecks of colour rather than the replacement of lakes, for instance when showing pops of flavour like spices or herb inclusions, our sparkles can be added. Let's move now on to real-life applications where we present natural colours as alternatives to artificial dyes and lakes. We'll start with reds. FD&C Red 40 is used in dry seasonings to enhance sensory congruence with hot and spicy flavours, to display identities like tomato or bell pepper, and it's even used to identify sweet, fruity profiles. With its bright fire truck red colour, Amaze Orange Red is a great option to use when replacing Red 40. In the sample shown here, the colour itself was pre-acidified to achieve that particular hue. With the intent to get a closer match to Allura Red or Red 40, we blended our Amaze Orange Red with some paprika, which neutralised the slight remaining purplish tones of the anthocyanin-based colour. When using Red 40 in an oil slurry, we were able to get close matches with a few natural alternatives. In the middle, we have our Mychroma Berry Red, made with red radish, and then on the right, we have our Amaze Orange Red. Doughs are a little trickier since heat-stable reds are required. Carmine or carmine blends can provide close matches, but is not always a feasible option when vegetarian or kosher claims are needed. Acidified anthocyanins can get close in shade, but may lean more pink or purple due to the pH. Now, let's see some orange colours. Often used in snacks, FD&C Yellow 6 or Sunset Yellow has a quite orangey hue and is warm and vibrant. It is an all-time favourite for snacks and seasonings to evoke intense cheddar cheese or spicy habanero profiles. Paprika pigments deliver a much more vibrant and intense colour, with a hue that is slightly less red-hued than the target. It is a great alternative to replace Yellow 6 dyes and lakes with a clean and familiar label that has somehow a culinary touch. Blends of paprika with an anthocyanin source, like Amaze Orange Red and Mychroma Berry Red, increase the redness of the colour for an even closer match to the Sunset Yellow lake used here. We mentioned Mychroma pigments as alternatives for artificial lakes in oil slurries, but we have other alternatives, especially when speaking about orange colours. Native oil-soluble colours like paprika oleoresin, beta-carotene and bixin are all orange colours with a diverse range of hues and have the advantage of being perfectly miscible with the oil in the slurry, which means that the colour will never settle or precipitate, no matter how thin the slurry is. In this slide, we see oil-soluble colours like paprika oleoresin and beta-carotene matching a Yellow 6 lake. For a more precise match, we can add a bit of red, like shown in the right-hand example. There are also plenty of natural orange options for extruded or heat-processed snacks thanks to the thermal stability of carotenoids. Again, paprika and annatto provide close shade matches alone, or they can be blended with a hint of red for more vibrant red-orange shades. Moving on with yellows. Tartrazine, or FD&C Yellow No. 5, in its lake form is slightly warmer than the soluble dye. Its hue makes it ideal for cheese snacks profiles, often in combination with FD&C Yellow 6. The closest match to tartrazine among the natural pigments is curcumin, extracted from turmeric rhizomes. It ends up being slightly more vibrant with cooler undertones when compared to the lake of the artificial colour. Beta-carotene emulsions and annatto extracts give a much warmer shade, but they still conform to a very satisfactory cheese profile. We see here again the use of native oil-soluble colour like annatto extracts, bixin-based, and beta-carotene that when well dissolved in oil look golden yellow. We also got a very good match for Yellow No. 5 lake with the use of Mychroma curcumin that has an improved light endurance if compared with regular curcumin emulsions. Similar to oranges, turmeric, safflower and carotenoids like beta-carotene have great heat stability, making them apt for extrusion and provide close matches to the vibrant shades of Yellow 5. For greens, blends of FD&C Blue 1 and tartrazine are generally used, and since the ratio of blue to yellow can vary widely, custom blends are typically needed to replace them. For both dry seasonings and oil slurries, Microma spirulina and turmeric can do the work. And for a wider range of greens, you can opt for other yellow colours like beta-carotene or other sources of blue like gardenia. Baked and extruded snacks will need heat-stable solutions like copper chlorophyllin, where permitted, or blends of a suitable yellow colour with gardenia blue. Blue is not a usual colour for snacks, but it can be utilised to hint emotions and sensations like in ultra-hot seasonings. FD&C Blue 1 can be substituted in dry seasonings and oil slurries with phycocyanin sources like spirulina. Microma forms are the best option for this because of their huge reflecting surface area and ease of use. The presence of acids in the flavouring systems of both dry seasonings and oil slurries wouldn't be an obstacle for the use of spirulina here because in absence of water, acids wouldn't interact with the pigment structure. Limited processing temperatures and times allow for the use of spirulina in small-sized baked snacks, and for more intensive heat treatments like in extruded goods, gardenia blue or butterfly pea could be an option with a different hue of blue. Similar to greens, a variety of purple shades for fantasy flavoured snacks can be achieved by blending FD&C Blue 1 and Red 40. But given the slightly orangey cast of Red 40 and the subtle turquoise character of Blue 1, the purples that can be obtained from their blends tend to be deep and dull, close to a grape or blackberry colour. Natural solutions with similar but sharper and cleaner hues can include blends of blues like spirulina and reds like radish or amaze orange red. Their micronized forms are apt to be used in dry seasonings and oil slurries. For alternative shades of purples like violet, orchid and lilac, blues can be blended with pinker sources of reds like beetroot, anthocyanins from black carrot or purple sweet potato. The latter mentioned anthocyanins can be used in extruded and baked snacks, provided a carefully designed process and an optimised rate of use. Our blue carmine, a purplish water dispersible form of carmine, also works well in heat-treated snacks. Now that you have seen some of the possible solutions to replacing artificials in snacks, let's re-examine some strategies to keep in mind when approaching this task. For doughs and batters that are baked or extruded, opt for heat-stable colours, preferably of a water-soluble nature, both in liquid and powder form, as required by the manufacturing procedure and particular recipe. Water-soluble colours will prevent bleeding in fried snacks if compared to oil-soluble ones. Dry seasonings and oil slurries shine their best with the use of microma pigments. The powder forms can be dry blended with the other solids in the seasoning or can be easily dispersed into the oil slurry. Either microma liquid suspensions or native oil-soluble pigments like carotenes and chlorophyll can be added into the oil slurry blend. They can also potentially be incorporated into the carriers used in dry seasonings through a plating process, similarly to how some oily flavours are added to these applications. As in any project that involves the replacement of artificial colours or their blends, always keep in mind the food matrix, that is, its intrinsic colour and chemical nature. Consider that the replacement may or may not imply the use of a combination of natural colours, and that the rate of use will very likely be increased if compared to FD&C colours. We can work with you to determine the best point to add natural colours to your process and talk through considerations for your preferred packaging format for an optimal colour stability. We hope you have found this information helpful in your natural colour journey. If you would like more information on how to replace artificials in your specific product, or for samples of anything you've seen in this presentation, you can contact us or request samples via our website. Thank you again for joining us today.